Alekia and my group members are Jeevita, Lasya and Shravani. Today we are going to present on water desalination. This is an artificial process used for generating the fresh water. We have a natural process, though why we are going for an artificial process? Because water is essential for all the living creatures, and usage of water is a continuous process. So fresh water is very essential to everyone. Without fresh water, our life is like a miserable. So as the population is growing, but fresh water is limited, so we are choosing the artificial processes. Water desalination is like a process where some amount of salt and other minerals are removed from the water, and a reusable water is generated from the water desalination. And this water is used for human consumption and irrigation. And what it is, we can call it as a distillation or desalination or desalination. It is mankind's earliest form of water treatment. It's not a new technology, it's old technology. All over the world they are using this treatment for the water. And desalination plants are used to convert the seawater to drinking water on ships and in many arid regions of the world. And perhaps one water treatment, this is one of the water treatment, though we have another sources of the water treatment, but this is used all over the world. This is the hydrologic cycle where the fresh water is created naturally. Generally, sun causes water to evaporate from the water resources like lakes, oceans, and streams, and this water is evaporated, and it creates a water vapor. And when this water vapor is eventually contacted with the cool air, it gets recondensed, and from then it again get back as a rain, so that we can use this fresh water. Though this fresh water, which is because of the natural process is insufficient to us, we are going for the artificial processes. What is the need for the fresh water? Though we are having the natural process, why we are going for the artificial? Because of the scarcity of the fresh water. Nowadays there is becoming a very need for the fresh water in the arid regions, and like it is becoming an issue like a fossil energy resources where we are in limiting of the fresh water. So in many arid regions we don't have the fresh water resources, and though we have the limited underground water resources, we are going for the fresh water in artificial process. Other sources of fresh water are the thermionic process and low temperature thermal desalination. In thermionic process, sodium and the chlorine ions are removed with the help of the energy resources like solar. In low temperature thermal desalination, the water is boiled at the low temperatures, and then after boiling the water at the low temperatures, the cool water is pumped through the coils for shrinking the evaporated water vapor. And this video shows the desalination process, but as it is a long video, my friend is going to be explained about the process in short.
So now we are going to see about desalination process, and first we need to pump the seawater from the any source, and then after pumping the seawater we need to establish the flow through the membrane, and this will cause the water to pass through the salted side of the membrane to unsalted side, and the rest of the water which is passed through the membrane is stored in the container which is more concentrated solution, and after that we need to remove the concentrated of the solution, and some of the water which contains dissolved salts, and the salt solution is removed from the container, and hence this reduces the more energy in the flow of osmotic pressure and produces the natural osmotic pressure. So we have three methods in desalination process. The first one is vacuum distillation and multi-stage flash distillation and reserve osmosis. So first we need to see about the vacuum distillation, and vacuum distillation is nothing but it's a method of distillation where by the pressure above the liquid mixture to be distilled in the is reduced to less than its vapor pressure, and causing evaporation of the atmospheric pressure, and those with the lowest boiling points. And this distillation method works on the principle that boils occurs through the vapor pressure of the liquid exceeds ambient pressure. And here we can see the vacuum distillation in the figure. So first we'll be taking the salt water in the flask, and when we heat the salt water, we'll be getting the purified water, which will be going to the container, water container. So the impurities will be stay into the flask, and then the purified water will be going to the condensed water. So from here we'll be getting the purified water, then after to the pump. And the next one is the multi-stage distillation. Multi-stage distillation is nothing but will be purifying the water in the different stages, that is like in 3 stages. So it is nothing but a water desalination process that distills a seawater by flashing a portion of a water into the steam. And in the multiple stages of what are essentially counter current heats enhancers. And multi-stage flash distillation plants produces 80% of desalination water in the world. So here is a diagram of that. Here we can see the multiple stages, first, second and third. First we'll be getting the first we will be taking the sea water, then we'll be purifying into the different stages. Then after purifying it, just go to the container. So after going to the container, the water will be heated. After heating that, heating that we'll be getting the purified water from the first, second and third stages to the pump, and then the discharge drain will be remained in the containers. So then we'll be getting the purified water. So the next stage will be continued, my friend.
Hi, this is a third method. Many of the countries are using this method. This is reverse osmosis, and it consists of membranes, like this type of membranes. This is mainly used when large molecules or ions are present in the water. If they pump the water into these membranes, then the water will be purified, and all molecules and ions will be separated from the water, and the people will be getting the pure water. And the positives of this technology are, like, as we know, every technology has pros and cons. This also has pros and cons. It has, like, the pros are improved fish habitat due to reduced diversions from rivers, streams and groundwater, and energy savings and less air pollution if the amount of water being pumped across the state is reduced. And the next will be greater protection of high quality groundwater due to reduced pumping of aquifers, drought relief. A typical American uses 80 to 100 gallons of water a day. According to the US Geological Survey, the entire country consumes about 323 billion gallons per day of surface water and another 84.5 billion gallons of groundwater. The price difference will undoubtedly narrow, especially in regions that could experience more intense droughts due to climate change. Water use has been growing twice as fast as population growth, causing more and more communities to suffer water shortages. The demand for fresh water supplies will drive prices higher, making desalination increasingly attractive. And the cons will be, the cost of desalination is about double that of water current sources, and we have to figure out do with the leftover salt, and also fish could be unintentionally sucked into the water intakes, and large amounts of energy are needed to generate the high pressure that forces the water through the filtered. Current methods require about 14 kilowatt hours of energy to produce 1000 gallons of desalinated seawater. And if half of this water came from desalination, the United States would need more than 100 extra electric power plants, each with a gigawatt of capacity. Depending on local energy prices, 1000 gallons of desalinated seawater can cost around $3 or $4. Although that might not seem like much, it is still cheaper in many places to pump water out of the ground or import it from somewhere else. and it is also implemented in globally, like different countries. Those are like Aruba, Australia and China. In Aruba, the island of Aruba has a large desalination plant with a total installed capacity of 11.1 E6 US gallons per day. And in Australia, they desalination help to secure water supplies. It is energy intensive and has a high carbon footprint due to Australia coal based energy supply. In China, they are also supplying in China. It has never operated at more than one quarter capacity due to difficulties with local utility companies and an inadequate local infrastructure. And the next part will be continued by Shravani.
Hi. Uh, Now I am going to explain about the enrollment issues on desalination. Actually, we have a lot of advantages about the desalination. Like we can convert the seawater as a drinking water, but there is a cause by the pollution because of mixing of chemicals into the seawater. And this construction process to be taking as a time taking process, and it is inconvenient to the all situations, and it is disturbance to the environmental. It is ideal to have as a little construction as necessary. And there is a risk of polluting the groundwater from the drilling process when installing feed water pumps. Leakage from pipes that carry feed water into the desalination plant and highly concentrated brine out of the plant may underground and cause damage of groundwater aquifers. One of the major pollutant of desalination process is chlorine. This chlorine is used to, the chlorine is caused to water pollution. The use of chlorine also leads the formation of oxidation byproducts such as halogenated organics. This technology is developed by the University MIT. It is used to this university researching on separating the seawater as a drinking water by using the by using a conductor to separate these. The conclusion of desalination is there is a great outlook for the technology of water desalination with the use of water growing at twice of the population growth rate. This technology will soon prove to be the most important due to the fact of the potable water is virtual of human survival. That's it. Thank you.
Very good. Any questions? Anybody thirsty? What do I have a question. What do they do with the salt that comes out of desalination? Do they throw it away? Do you have
Yeah, actually, that is a con I explained you.
The what?
Actually, there's no place to put the salt. It is the disadvantage for this process, actually.
salt is massive. We don't have place to
Yeah,
put
yeah. This
So-
is the disadvantage.
it. Okay. Any other questions? Salt and sugar. Yes. Another question here.
In one of the slides, you talked about the high carbon footprint that it leaves in Australia. I was just wondering if you could kind of explain more about that. What does that mean exactly? That it leaves a high carbon footprint. I think it was.
What do you mean by a high, what's it?
A high carbon footprint.
High carbon?
It was in your slide about Australia.
So when Australia does this thing, they leave a footprint, a carbon footprint, very large. So they actually pollute the environment. So did you read anything about what to take care of that? Now we have salt filling the earth, and we have carbon filling the environment, and we have few pieces of water or few drops of water. So is it worth it? Now, let me tell you something about Dubai. When I was there, they were so proud of desalination of water. They take, because they don't have any resources, so they take the water and make this. So it is successful there. I didn't ask them where do they put the salt, and I didn't ask them about the carbon footprint. So next time I'll do that. Other questions? No. So, yeah.
I'm sorry, I have no idea about that.
Okay. So it's something for further research. How about that? Further research. You please research for
Yeah,
the
sure.
footprint of the carbon, and please find us something about the salt, and then email us when you graduate.
Sure.
Okay. Please join me in thanking them for this presentation.